we doing, guys? It is Mr. Striz, and I'm checking in. Hold on one second. I need some water. Have you ever just thought when you took that nice sip of cool water, man, that's some high quality H2O. I wonder what properties make up water. Well, if you actually have asked that question before, we're going to take a look at it today. So what we're looking at is the different properties of water. And when you think about it, you're kind of, water's so much around us, you probably never really thought about, man, I wonder what makes water water. Because we kind of just think, well, water is water itself. So looking at our LEQ is identify and list the properties of water that make it essential for life. So for life to be the way it is, a lot of it deals with, the properties of water and why they're so important. And it's actually really interesting when we get into it, those properties of water and how, without water being the way it is, our lives would be completely different. So when we take a look at water, the first thing we're going to be looking at, what is the structure of a water molecule? So when you see this picture here and you see that structure, what a water molecule is it's a polar molecule with 2 hydrogen, 1 oxygen, aka H2O. So you have 2 hydrogens here, and then 1 oxygen there. So once again, that structure of water is a polar molecule with 2 hydrogen and 1 oxygen. Now, we're moving on into why is, water a polar molecule? We just talked about it being one, but what makes it a polar molecule? So water is a polar molecule because the oxygen is a negative charge and it pulls the positive hydrogen molecules towards it. So if you notice here, you got the negative charge oxygen and the 2 positive charge hydrogens. And so those act like a magnet almost. When you think about magnets, we talk about how the unlike poles attract each other. So the north end of the magnet attracts the south end. Same things here. The negative charge oxygen attracts the positive charges. So that's why a water molecule looks like the way it is. And that's why it's a polar molecule. It's because the oxygen is negative charge and it pulls the positive hydrogen molecules towards it. Now, water is also known as, not known as, but it's a hydrogen bond. So what that means is that an attraction between the positive hydrogen and negative oxygen. So it kind of goes back towards that like magnetic example we talked about. The positive is attracted to the negative and it makes a hydrogen bond. And notice though, remember when you think about magnets, the same side poles you can't push together. They repel each other. They're the same likes can't come together, but the negative and the positive do. So that's a hydrogen bond right there, and that's why water also forms a hydrogen bond there, because that negative charge attracts to the positive charge. And it's because of these two things that water has these unique properties. And the first unique property that we're going to be looking at is cohesion, and that's going to be cohesion and adhesion. So cohesion is where water molecules stick to other water molecules. So that's, as you see here in this picture, that water molecules bead together. It's because of that cohesion. Think of it like a glue almost, where the water molecule, H2O molecules, stick to other H2O molecules. And then we have adhesion. Adhesion is when water molecules stick to other substances. So you see these water molecules stick into I think probably like a leaf or something along those lines. But once again, that beating right there of the water is because of cohesion, and adhesion is when the water molecule sticks to another substance. So that's the first property of water, that we're looking at. And the second one we're going to be looking at, and probably, they're all very important, but maybe one of the more important ones is the high heat capacity. So when you think about high heat capacity, think about Florida. All right, notice that Florida is surrounded by water. on the three different sides of our peninsula. So high heat capacity is it takes more energy to heat up water. And think about it in the sense of boiling water. Like, it takes a lot of energy to boil water compared to other substances. And when you take an account into Florida, I want you to take into account, the temperature. If you look at the average temperature in Tampa, so if you notice the average temperature in Tampa, the high usually gets, up to 90. That's the average. The lowest it probably gets to around 53. So that's the difference of, around 40 degrees Fahrenheit in temperature. Now let's take a look at the average temperature in Chicago, Illinois, a Midwest town. The average high is around 85, the average low is around 15. So that's a 70-degree difference between the two. And that brings me back to the point of Florida being surrounded by water. So because we have so much water, it's able to have a more balanced average temperature because because of that high heat capacity, where it takes more energy to heat water up. So that's why we never get too high or we never really get too low, is because of that. So once again, that's high heat capacity, where it takes a lot more energy to heat up water. And then the next one we're going to be looking at is expansion upon freezing. Another very important one when it comes to the properties of water, because of how those molecules react. So water expands when freezing, which allows water to become less dense and float. If you notice here, you have a water bottle, and when it's frozen, it looks like this because it is expanding. And because of this, you never really maybe thought about it in this point, but the ice cubes, water floats when it's frozen, and not many substances are able to do the same. But why that's so important is because our Earth would look like this if water didn't have that unique property. We would be a frozen tundra, and probably life on Earth wouldn't happen because of 75% of Earth being water. That then becomes 75% of Earth being just frozen. But because water is able to float, our Earth doesn't look like that. It's that, notice when you think about lakes, during the winter, they freeze on the top, but there's still water at the bottom. That allows all those fish and all those aquatic ecosystems to survive because that ice is just on the top. It's not completely frozen. So that expansion upon freezing is another unique property of water, where water expands when it's frozen, and then ice becomes less dense, which allows it to float. Now, the last one, and we kind of see this probably more often than not out of those unique properties of water, is a universal solvent. So when you think about the universal solvent, water is able to break apart or dissolve more substances than other liquids. So if you notice here in this picture, it looks like they maybe dropped a Tums or something in there, and it's starting to break apart that substance. And it's kind of a misconception per se, but when you throw like a substance in water like that, it doesn't just disappear. That substance just doesn't disappear. It's broken apart. And that's, once again, because of that universal solvent, where it breaks apart or dissolves more substances than other liquids. And we're kind of getting towards the end here. Capillary action. Another important one, the ability of water to flow upward with no resistance. So if you notice here with our plant picture, that because of capillary action, that's how plants are able to get water to move up through the root system. So you have their roots right here, and they're soaked with that water. And because of capillary action, that water is then able to be shot upward, through the plant, so it can get to the leaves and through the rest of the stem there. So capillary action is another unique property of water, because water is able to flow upward with no resistance. It's not like it's having this pressure that's being pulled upward. It's just able to, because of that adhesion, that able to flow upwards, specifically more in the sense of plants there. That basically brings our end to the video here. And once again, it's looking at that water molecule. You never think about just having water, drinking water, how important it is to Earth's survival. And we went through those properties, so make sure you get that LEQ at the top and make sure you write a summary for that LEQ. From there, make sure you do the USA Test Prep quiz and then do page 16 in your notes. This is Mr. Striz signing out.